came from Marlborough, Vermont tonight, and we're going to talk about fishers. Do you want to hit the lights? Okay. There we go. We can see the picture now a little better. Has anybody had the opportunity to track fishers in the wintertime? Snow tracks, right? They're a pretty exciting animal to track in the winter. They're really one of my favorites to track because in a short amount of time, you can really see them do lots of interesting things, lots of neat behavior, from hunting strategies to maybe finding a kill site, and etc. So I'm here to share a little bit about tracking fishers in the northern forest. So we're going to talk a little bit about some biology and ecology of fishers. And we're also going to talk about this other part, which is my thesis work that I did at Antioch. It's testing GIS-generated least cost path predictions for fishers and its application for identifying mammalian road crossings in northern New Hampshire. So it's a long title. We're going to go through the title and break it down, all the pieces, exactly what that means so you understand it. It's kind of an important part to what we're talking about because it fits in quite a bit with kind of what Linking Lands Alliance is doing in terms of looking at maps, thinking about how animals are getting from point A to point B, moving on a landscape that has a lot of roads and other types of fragmentation. So that's kind of what that work addresses. Just on to the next slide. When I went to Antioch, one of the major things that I was really interested in was the subject of road ecology. And what that's really looking at is how roads are impacting wildlife, from vehicle mortality. Roads can subdivide populations, increase the risk of mortality, like I just said, and fragment connected habitats into isolated patches. So, when I went there, I was interested in that. But just to back up a step to why I got interested in that in the first place, we're just going to talk about red foxes for a minute. This was a thesis that I did for my undergraduate at Marlborough College. And what I was trying to do there was determine red fox habitat preferences as well as home range characteristics. So that whole winter, while I was there, I would drive the roads in the morning, driving roads, and I'd just find trails that would cross the road, and I'd get out of the car and see if it was a red fox, and then I'd take it for the rest of the day. But while I was driving the roads, I started to look at the landscape completely differently because I started to see not only where red foxes were crossing the road, I got to see where deer were crossing the road, where fisher were crossing the road, and lots of other animals. So that was quite an interesting exercise, and I started to notice some patterns. So this is the center of Marlborough, and all these red lines up here kind of indicate a red fox trail that I had followed that winter. And if we zoom in kind of to the center of town in Marlborough, there was a lot of activity right around the center, and to kind of zoom in, that little yellow square is what we're looking at here. The foxes, and not only foxes, a variety of other fisher and bobcat, other weasels, were crossing in the same spots kind of repeatedly, right around, this laser pointer works, here's the center of town, kind of in this little forested patch, coming through here, and then crossing over here. And that kind of sparked my curiosity to want to explore this subject further. And that kind of led me into thinking about ways that we could predict where these crossing locations are. And the title of that paper, with the least cost path that I was talking about, that's a certain way to model road crossings. And if you find good road crossings that way, you might be able to provide conservation for roadside habitats, maybe put in bridges and culverts and things like that. So that's what I studied there, and we'll talk about that a little bit. So the central focus of my research was to evaluate the single species corridor design. And then I wanted to actually test it. So I wanted to go in the field and then see if the prediction of the model was correct. And that was a pretty novel idea because a lot of these models are really not tested. So it was important that we would be able to empirically go in the field and give some feedback to whether the model worked or not. This is where the fisher comes in. And this is where we'll take off on the fisher for the rest of the night. I chose the fisher as the focal species because these models are often built around a species with certain requirements. And we'll talk about what those are for the fisher in a moment. my questions for the study were, do these model corridor method, does it actually predict where the wildlife is crossing roads? And do the road crossing locations used by fishers provide movement corridors for other terrestrial mammal species? So what I was trying to do with the fisher was say, I had a feeling that, well, maybe the place where fishers are crossing the roads is where lots of other animals are crossing the roads. So if you find places where fishers are crossing the roads in other parts of the New England, you might find places where all these other critters are crossing the roads. And I'll talk about why I selected fisher for that in a moment. But that was some of my reasoning why I selected fisher for the study. And I wasn't the first person to really think about this, and I didn't know it at the time, but whenever you take on a academic question like this, it's always important to see if anybody else has, first of all, done the study, then I don't have to go out and do it, or just see if anybody else has dreamed up the idea. And this fellow Linhan, for his master's thesis, which that paper later on was published, he was thinking about fisher as and river otter as species that would be indicators of wildlife crossing zones. He thought the fisher was a good example for ones that were for terrestrial mammals, whereas the river otter would be a better indicator of species for the riparian zones. So, okay, now why the fisher for this project? So I used this focal species selection criteria, which is by this fellow Paul Beyer, who is really a major figure in the corridor designing framework. So you got to pick a species that is area sensitive. So the fisher, in some circles and some researchers think that fishers are sensitive to fragmentation and development. However, more recent research is starting to think that fishers might not be as sensitive as once thought, because they are starting to be found around suburban and more developed areas, and even starting to expand their range further south, all the way to northern New Jersey at this point. So, they're somewhat area sensitive. However, one point on that is during the early 1900s, fishers were basically almost extirpated, meaning almost wiped out from New England due to extensive forest logging and trapping. So the species definitely is sensitive to forest removal for sure. Habitat specialization was another thing. Fishers really select lowland coniferous forests, overhead story. They're rarely found out in the open areas. Very seldom will they go through the middle of the field. I've never actually seen them go through the middle of the field. I've always seen them skirt maybe just on the edge, but they're always deep into the forest. So they're pretty much specialized on that type of habitat. Overhead cover is important. And that gets back to one of the reasons why I was thinking fisher would be a very good species for finding corridors, was because of this preference towards the overhead cover. Other animals might move through those areas as well and avoid open areas. So that was one of the factors. So he also feels that the animal you select should have a short or habitat restricted dispersal. So when juveniles are born, they're going to disperse at some point. The fishers have a short dispersal, only 10 to 20 kilometers. And so they're really only moving a short distance from their natal range, which is not very far to recolonize new areas. And that dispersal should be necessary for the metapopulation persistence. So that's basically dovetails with the third one I was just talking about. That has a lot to do with the idea of source and sink type populations. Fishers really need on the landscape source populations where they're just going about their daily business, they're not being impacted that much, and the juveniles will disperse to the sink populations, which will locally become extirpated, but the source population will continue to generate new individuals that will go to those locations. Barrier sensitivity is another criteria. There's not a lot known on fissures of whether roads are barriers to fissures or whether streams are barriers. Some researchers think that big rivers, large streams are barriers, but not much is known if that was a specific factor. So I couldn't really say a lot on that one. And then ecological importance. Fissures do play a really important role on the landscape in the fact that they predate on porcupines. They're a really major predator of porcupine, and in the 1960s, because like I said, they were pretty much extirpated from the state before that, in the 1960s they were reintroduced. 120 in this state, 120 individuals were released from Maine to help boost the population again to control porcupine numbers, and they successfully are doing that. So let's talk a little bit about some fishery ecology. This is a map of Marlborough, and it's where I'm from, the whole town. It's a nice study area to look at because it's 10 kilometers long by 10 kilometers wide. So if we throw up a grid on there, each of these little squares here represent 1 kilometer, and there's 100 of them up there. So we're going to talk about home range and density, and hopefully that map there will give you a sense of how big a fissure home range is. And home range for male fissures can be about 19 square kilometers, give or take, plus or minus 17 kilometers. So let's just say, 25 square kilometers, we'll just use that as a number, would be a quarter of Marlborough. And of course, these home ranges are never going to be just perfect squares like this. They're going to maybe border a road or a stream or something like that. But this just gives you a general idea of the size that this male fisher could be traveling. And in there, so on the map, these are all, these black lines, roads. So he's crossing a lot of roads, and there's all sorts of houses along this area. And because I live right about here, I know that there is fissures all through this whole area. It's always neat to kind of think of, well, how many are out there? What's this individual doing? How much area would he actually or she actually cover? So females have a completely different size range, territory. Theirs is much smaller. It's about 15 plus or minus 5, and their ranges will overlap with male ranges, but their range will be exclusive of other female ranges. So typically a male range will cover maybe 2 or 3 female home ranges. So there's another way to look at this too, and this is a density estimate. And so suitable habitat and unsuitable habitat. And I forgot to mention, all these numbers I'm throwing at you were done by this fellow here, Kelly, in 1977. It's a little old, but it was a radiotelemetry study done in the White Mountain National Forest, which is the closest study that's been done to this region. So it was the best one to use. Most of the estimates that I'm giving you are pretty much similar to what other researchers are finding, except the fissures out west tend to have bigger home ranges. So, but mostly for New England, the ones that have been studied in Maine have similar size home ranges. For the density estimate, we can look at this one of two ways. You can look at it as, how many animals per kilometer, and you always come up with some weird number like, 0.11 animals. How could there be 0.11 animals in 1 kilometer? Another way to look at it, easier to think about, is, how many animals, kilometers squared per animal. So how many kilometers per animal? And for the suitable habitat, you might have one fissure out there, if it's a really great habitat, in 4 square kilometers. And here's the upper range, 7.5. And we'll talk about what suitable and unsuitable habitat is in a little further on. But unsuitable habitat, just to give you a size of what that looks like, 9 square kilometers would be something like that in unsuitable habitat. So let's just play that out for fun. like I said, this is simplifying nature, which is easy to do with a map like this. But let's say we have 4 male home ranges out there like that, and 8 female home ranges, something like that. Super simplified, but if you ever do anything like this and you're interested in asking, it's a good way to start thinking about how many of these critters might potentially be in your town. If we do it the other way with the density estimates that I was giving you, and I just decided to set a density at about 6 kilometers squared, somewhere in between the suitable habitat. Obviously not all of the town is suitable habitat, but a good portion of it is. We'd have 16 total fishers out there as a way of looking at that. This is kind of an unusual looking home range, but okay. So sexual dimorphism between the male and female in the species is really pronounced. And what I mean by sexual dimorphism is that this male fisher is twice the size as a female. And a male could be really big. I mean, they can be almost 4 feet long, and about 1/3 of that is tail. So they're pretty big. They're pretty big critters, and females, like I said, are half as small. Sexual dimorphism is really important in the species for, remember I was showing you the home ranges, how the male territory will overlap a bunch of female territories? Well, the reason that is that they won't compete for resources as much, that is the male and the female. Because the males are larger, they can take down larger prey, and the female can specialize on smaller prey. So they're not really competing for resources as much. And that's pronounced in their skulls, too. So this is a male fisher skull, and this is the female. And you'll notice right here where the 2 parietal bones form together, those are the bones back here on the skull, they connect to form a sagittal crest, which is this little mohawk-like thing. And the bigger that is, the more muscles can attach to that. And the muscles that attach to that are called the temporalis muscles. And we're pretty wimpy in terms of that. We don't have any sagittal crests. I mean, if you bite down, you don't even feel any muscles move back here at all, right? Because most of our muscles are these masseter muscles, which really control grinding and chewing back here. But this temporalis muscles actually control the biting force kind of at the end of the mouth. So if you ever get the chance to see like a hyena skull, they have a sagittal crest. It's like this big. They got these huge muscles. They can crack bones, and but so the fisher, that's pretty big for this size animal. So there's a picture of the sagittal crest. And on females, it's not really pronounced. So that's just showing you how these differences in size and how the difference and how the skull basically reflects the different types of foods that these animals can prey upon. So they're almost like 2 different species, almost, being that they're so different and there's such drastic difference in the size of the skulls. And the tracks is another way you can tell between sexual dimorphism between both of them. These 2 up on the upper side are female-sized tracks, and the male tracks are these ones in the lower portion of the screen. And this is really easy to do in the field, and here's a good estimate if you're out there looking at tracks. Paul Resendes gives this number, which holds pretty well. Tracks under 2.5 inches wide are likely female, and tracks over 2 5/8 were likely made by a male. So you really only have 1/8 of an inch to deal with there if you want to look at males and females. The nice thing about that is that the juveniles are pretty much adult size by September. So even in the winter, you're going to be dealing with these track dimensions and don't really have to worry about, well, is it just a small one? I will say that marten tracks, another weasel, mustelid, which I forgot to mention, fishers are not cats. They are weasels in the weasel family, carnivores. And because many people always attach the fisher cat, the cat at the end of it. Fishers are a weasel. The marten that I was just talking about is also a weasel. And it's much smaller than fishers. They only weigh maybe a large one, maybe 2.5 pounds or so. But that marten foot can look like a male marten, because they have sexual dimorphism as well. A male marten can have a track comparable to a small female fisher. So there's a little bit of overlap in there that you have to pay attention to if you're thinking about martin and fisher. We'll talk about the river otter in a moment. Okay, so for their reproduction, this is really, they're pretty neat in reproduction as well. In the middle of March, you have birthing of 1 to 5 young, or 1 to 4. And then you have mating. You're scratching your head like, what happened there? I mean, this is going this way, right? So birthing, then mating. Yep, that's the way it works for them. So 10 days or so after the female gives birth, she's mating again. And then there's what's called delayed implantation, which means that the egg is fertilized, but it hasn't implanted into the uterus wall yet, all the way till January, so middle of February, I mean. And then the egg implants then, and you have a 50 or 60 day active pregnancy then. So, in some way or another, the female is in some stage of pregnancy more than 11 months of, 11 and a half months of her life or so. Pretty interesting. So what are some of the reasons for why that is? There's a couple reasons that have been thought about, which seem pretty good. Right around March, April, snow's starting to melt. So for males searching out females, and I forgot to mention the whole territory thing that I was talking about and showing you those squares. Males during all other seasons don't have overlapping home ranges. But once the breeding season comes about, they're all over the place. All that breaks down, not for females, but for males. So the snow's a lot less. You start getting that kind of crusty snow in March, freeze and thaws and things. So they can really cover a lot of distance, and they're going to go and find as many home ranges of females that they can find. So for one reason, it's easier for males to find females with less snow. And then the other reason is, let me think here. Oh, yeah. When the young are born, they'll have all this time, and I'll show you in these next slides, to develop during the warm months. So, they're the younger born. They're weaned in July sometime. And like I said, the young reach their adult size around beginning of September. And then the young begin to disperse sometime between November to February, 10 to 20 kilometers away from the natal home range, which is not very far because, like I was saying, the home ranges are only about 10 to 20 kilometers, so they're really just moving right next door. And the reason that's a problem for this species is if they're not moving very far, if there is great habitat over there, it's going to take them a while to get to that spot because they're basically kind of leapfrogging through generations rather than just picking up and going, 50 or 100 kilometers. That doesn't mean they don't move a lot within their home range. In fact, they're pretty vigorous. One was documented moving like, maybe 40 miles or 50 miles in 3 days, just doing circles, hunting around its home range. So they could really be on the move. Just to finish this up, so the first year females, once they've gone all the way around the circle here, they'll breed their first year. The males can breed their first year, but they're really not very successful at it. So they don't breed usually till the second year. And they're pretty, that's a kind of cute picture of them too. Thought I'd use that one a bunch. Okay, suitable habitat, unsuitable habitat. Suitable habitat, generally, like I said, conifers, so that's needle-leaf trees, pine, spruce, fir, coniferous cover, that's what I've been meaning by that. Unsuitable type of habitat is more like this type of patchy zones with open fields, houses, roads, etc. Hardwoods are somewhere in the middle. They're not used really all that frequently, just moving straight through. But most of their food and things they're hunting for are going to be kind of in this type of habitat, so that's where they spend a lot of time. The other thing seasonally is, like I'm talking a lot about winter here because we spend a lot of time learning about fishers, but a lot of radiotelemetry studies show that home ranges actually shrink during the summertime because there's more food and resources available, and their use of their range changes a bit, and they might actually be spending a little bit more time in this type of habitat in the winter because the trees will hold a lot of snow above it, so there's actually less snow underneath the canopy here, and the fishers can move around a little bit easier. So depth of snow is often a limiting factor for these fishers. They like to avoid deep snow, and they'll walk a lot more in deep snow, where they often do a bounding type gait, which I'll show you a little bit later. I won't do it personally, but I have a slide. I've tried it. But yeah, so they'll change their gait a lot in deep snow, which means they're conserving energy. So on the ground, suitable habitat often looks kind of like this, dark overstory. They'll do a lot of hunting. This is a tree that a fisher had climbed and tore out a mouse nest here and ripped the tree apart, and the debris of it's down there. Okay, so foods and feeding. Anybody want anything else? The porcupine, and this little 1 month thing here is kind of interesting. So if a fisher kills a porcupine, that food is going to be about a month's worth of food for him, which is a pretty good deal. Tough kill, though. So the reason I set these two pictures up like this is for a specific reason, because the fisher's head, and this is what makes them such effective predators of porcupines, is their head level is right at the head level of the porcupine. And that all goes about their hunting strategy and how they go about killing a porcupine. For bobcats and cougars, picture a bobcat or a cougar or any type of cat. They also prey on porcupines pretty regularly. Canines not so much, but bobcat and cougar, their head is above the porcupine. It's like somewhere up here. So whenever they go for a killing bite on a porcupine, where are they going? They're going for the back of the neck. And that's not a place you really want to bite on a porcupine, so they'll get quills in their face and stuff like that. They can successfully kill them, but the fisher is perfectly designed to predate porcupines, because what the fisher does is it finds a porcupine on the ground somehow. Some researchers say that they'll climb up a tree and walk a porcupine out on a branch, and the porcupine will fall off and then get on the ground. And then they'll circle around this fisher, kind of bobbing and weaving, dancing around, and they'll just keep taking bites at the exposed fleshy part of the porcupine's face until the porcupine is so delirious, kind of worn out from the experience, that the fisher can just flip it over, get to the exposed underside, and basically just kind of skins the porcupine out. And you'll just have basically, in the wintertime, I've just found like porcupine pelts, just the top quills perfectly skinned out. And they just get moved around all winter. There was one winter near my house, I found the pelt over there, and then half a mile it was over this way, and things just kind of moving around. So those will remain a while. So like I said, 1 month worth of food for a juicy porcupine. Hare is a really important food source for them, probably the most important. And killing a snowshoe hare would be about a week's worth of food. And the way they go about doing that is fishers will zigzag through, a thick understory, just trying to flush the hare out. When the hare jumps, they're hopefully in striking range or close enough to be able to pounce on it, wrap around it, do the bite on the back of the neck to take care of the hare. One other thing, if you're ever following a fisher and you see, because you'll see all this stuff on the trail. In fact, one of my favorite classes that I teach at Antioch is when I have students read a bunch of information, like 3 or 4 journal articles on fisher, and then we go in the field the next day. And those articles are all like on home range and habitat preferences and feeding behavior and all that. And then we go out and we follow a fisher. The hard part, of course, is always finding the fisher, but so far I've been successful in finding one. We find the fisher tracks, and then they could see everything that the fisher's doing right there in the trail, which is really a neat learning experience to read about all this stuff and then see the fisher doing it right there. So if the animal, and you're following it, is zigzagging, weaving back and forth, well, this is probably what it's doing, or for squirrels or something like that as well. if the fissure is just moving like in a beeline from point A to point B and it's going through hardwoods and it's not making a lot of turns, it's quite possible it's either going to a denning and resting spot or it's headed to a place like a rocky cliff slope where you can find porcupines. So researchers and trackers, people who've observed fissures in the snow have just seen this countless times over and over again, same type of strategies. So 2 squirrels would be about a week's worth of food, flying squirrels as well as the red squirrel. And these are probably just gotten on the ground, not in the trees. Fisher is an excellent climber of trees, can climb trees well, and it can turn its rear foot around 180 degrees like a squirrel and come down the tree head first. So they're kind of very squirrel-like in that fashion. And if they're not doing any good with any of these food sources, you can just make a living on 2 to 22 mice a day. I don't know why the range was so wide, but somewhere in 2 to 22. And they'll also eat small birds, maybe grouse. They will definitely eat grouse and probably turkeys as well. Scavenging deer in the wintertime or moose is also an important part of the diet. And why not throw a little fruit in there and acorns? The Fisher type scat is a weasel type scat. Most weasels have scats like this. The Fisher is just a larger type of scat. It's a coiled, twisted type of ropey thing with hairs packed in it. If it's eating fruit, it's a little bit looser, and it will contain some seeds in it as well. Okay, so why the Fisher again? Here's some examples of some tracks and some trail patterns. This is what your typical pattern in the winter looks like. And why the Fisher, getting back to the study that I was talking about before, well, I thought, well, geez, hey, if this animal is a good focal species indicator of a good crossing, and if we want to have volunteers out there, people who don't spend a lot of time tracking all the time, the Fisher's track pattern and trails are really easy to identify. There's not many other species in the wintertime that leave this type of configuration. So you can get people out there in their towns and whatnot looking for Fisher trails, and if they find a Fisher trail, I'm not going to say it's 100% an awesome crossing spot, but at least it's something to pay attention to that you might want to come back and check out. So that was my reasoning for thinking about Fisher as well, from a tracking perspective and from a novice tracker perspective. The ease of identification would be really useful.
Their claws are always out.
They are retractable claws, but they generally show in the tracks. Yeah. So yeah, here's a track. These are all 5 toes. These are the claws you see up there. I mean, they're really razor sharp. So they can keep them back most of the time, and they come out when they're pouncing to grab prey or climb trees. Let me just get a drink of water. So, whoops. Yeah, so they have 5 toes on the front foot, 5 toes on the rear foot, even though it looks like 4. 1, 2, 3, 4. There's some nice claws up there. Heel pads. This region really kind of extends back on the track there, so it leaves kind of like a snow cone type shape to the overall track. Coming up, big rounded thing on the front. Okay, so river otter is another species that can be confused with the Fisher. River otter, if you're lucky, if you only have a short section of trail, like let's say you're just going along a road, the river otter might not do a slide, because river otters are known for doing these slides in the snow. So another feature you can look for, if you don't have any sliding of the river otter, to say that it's not, say that it is a river otter, not a Fisher. The rear feet on the river otter, so this is a rear foot and this is a front foot of the Fisher. It's the reverse on the river otter. So the river otter has a bigger rear foot and a smaller front foot. So you can use that as a clue too. So this is the bounding gait I was talking about. So in each of these marks in the snow here, 1, 2, dun, 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 this is where it's basically kind of what the animal is doing here. In this mark there are 4 feet. The 2 front feet land like this, and then the rear feet will land inside where the front tracks landed, right in here, and then it will proceed on in this bounding type of gait like this, and then launching off with the rear foot. Another typical track pattern, and like I said, this is very distinctive. There's not a lot of other species in the woods around here that are going to leave that. Marten and mink and well, there's lots of that do leave it, but in this size range. So we're talking 4 or 5 inches wide by 6 inches long. That little track group, and then a pretty good leap to the next one, anywhere like 50 to 70 inches sometimes. The other type of trail pattern they leave is like this, where you have the 2 front feet landing and then the 2 rear feet landing, and then if I were to go up any higher to the next set, you'd have that same pattern repeating itself. So there, the front feet are landing like this, like separate, so they're spread out like that. This one I can almost do, but I'm not going to do it because I'm all tied up with this thing.
Is that a normal gait, or is it in summertime, no snow, is it different?
Oh, that's a good point.
Walking?
Yeah, so this is the normal gait. They're going to use either of these probably in the summer or the winter, but there are differences in the winter. So if there's a nice good crust on the snow, like this photo, this is a nice crust, the fisher's going to use this gait. Whereas if it's deep snow, like you can see how deep these tracks are sinking in, it's going to primarily use this gait because this is a more energy efficient gait, because first of all, the 2 front feet have already broken a hole in the snow, so for the rear feet to land into it, they'll just land right in. It doesn't have to break a new hole in the crust. Whereas if it's nice hard crust, the fisher will switch to this gait because now it doesn't have to really worry about breaking that first set. So you can read a lot about how much energy the fisher is wanting to expend in its travels by looking at those track patterns, like you're saying. In terms of summer, I would assume they're probably going to be back and forth in either of these. If it's really deep snow, they will just move to a walking type pattern. And I didn't show you a walking pattern, but that's just basically like an alternating zigzag type pattern, just like our feet, just walking like that, except they have 4 feet down, but one paw will be landing in the same, so it looks just like a trail we would leave on the ground, like a cat tracks or dog trail walking like that. But this is their mode, and the reason, so the reason they have to stay in this is because they're this long tubular shape, right? And that's not a really efficient shape if you're trying to conserve heat in the winter. If you're nice and tight and condensed, you're going to conserve your energy a lot more. So this animal is long, spread out, it's losing heat to the environment a lot faster. So it really wants to move fast and look for prey as it's moving. So it's designed to do this bounding. It's always on the move, pretty voracious, looking for food, and this is how it can cover the most ground efficiently. Okay. So that's kind of the biology ecology section that I wanted to cover. This section is now going to talk a little bit more. It's going to kind of totally shift gears. I want you to keep thinking about the other information, because all that information on the biology of the animal is influencing all the decisions for why I chose it for the study. So remember, the central focus of this whole study was to evaluate that corridor model, corridor designer process. And then I wanted to test the predictions. And this is the important part, because this is where the fisher comes in. So we created the model based on roadside observations of fisher. So we already drove this road, 24 miles of road, and took information on all sorts of different species crossing this road. Then we took the information on just fisher and said, where are all the spotch fisher across the road? Well, in this GIS. So GIS is like a mapping type software. You can create all sorts of really neat maps with it. In there's lots of little cookie cutter type shapes you can do, and you can get a land cover. It's called a raster. I don't know why, but an aerial image of the habitat, and basically say, well, what's the percentage of hardwoods or conifers or wetland in that area? So around all the areas fisher cross the road, we basically did that. We just said, what's the habitat where fishers cross the road? And it would say this percentage of conifers, this percentage of hardwoods. So we built the model with that information in mind. And then, of course, we used our own reasoning on it and some of the scientific literature to support our reasoning behind things. So what did I want to test? Well, I wanted to know where that corridor, where that model predicted where animals would cross the road, were there more species found at that spot compared to random locations? You always got to test it to some random spot somewhere along the road. And then, were these species, the species we thought were sensitive to habitat fragmentation, bear, bobcat, fisher, were they showing up at those places where the corridor was at the road more frequently than the random locations? Okay. If you've got any questions during this, if it gets too technical, just stop me and I'll clarify things. So here's the study area. And remember, this is 24 miles of road, including Route 12. This is in northern New Hampshire, just north of the White Mountain Range down here. Towns of Jefferson and Randolph. And so we conducted the roadside track surveys along there. The entire road was sampled. We just drove the road slowly about 10 miles an hour, looked out the window. If we saw a trail in the snow coming up to the edge of the road, we'd hop out, we'd take information on it, record the species. And the roads were sampled 51 times from beginning of December to late May. And so when there was no snow on the ground, we were primarily looking for bear tracks and moose tracks on the side of the road. All the other small species, we really couldn't get much information on them. We thought that the winter data would be enough. And then we collected this 7,000 observations of 21 mammal species along that road. So that's a pretty big data set to work with for this type of study. So now back to the computer. I use this corridor designer software, which is kind of neat. All you have to do is plug in information and it just spits out this little corridor, and I'll show you how that works. For this, you need like 2 habitat blocks. You need a block up here and a block over here. This is Route 2. I put Route 2 in the middle. And basically I had a kilometer on either side of the road. So you have to do, this creates a, so you take all this information on fisher habitat preferences and it creates this background surface, which finds areas that the fisher will be optimal habitat, which on this little thing is the white zone. The black here is areas that are strongly avoided, and the different shades of gray are somewhere in between. So what the model is going to do is it's going to say fishers are most likely going to travel in their optimal habitat, and it's going to create this little thing. It's going to try and connect all the white zones up to here, and that's exactly what this little red line here indicates. It's just saying fishers are most likely on this landscape based on the information you gave me about how fishers select habitat. And this is based on the land cover roster. So underneath this little gray-white thing is all different types of habitats, hardwoods, conifers. So right now, this is probably a coniferous patch, conifers, mixed forest that it's trying to connect. And that's how fishers are going to get from block 2 to block 1, and this is where they're most likely going to cross the road.
What's that horizontal stripe represent, you know, in terms of what grows there? What would
This one right here?
well, the middle one's obviously the road.
That's the road.
Up above or the one below.
This one here? Okay, that one is a power line corridor
Okay.
that's bordering the road. This is probably just like a large agricultural field. This one could be a bunch of development, townhouse, subdivision or something like that back there. So it's just looking at all those things, and this right here is probably a bunch of conifers, and in between is probably just hardwood forest, something like that. So a good way to look at it. Well, you'll see why I'm saying that in a moment. So in the study area, this is what I'm comparing here. Where the corridor across the road, I created this 250-meter buffer, this circle around here. And remember, we drove the road originally, so we've got mammal crossings along the whole road. And basically, I just kind of clipped out, that's a word you use in the GIS, all the mammal observations that were found in that zone. And I did the same thing for a random location. And the random location, all you do to get that is in the computer, you just say, find random locations, and it just goes boop, 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 all over the place. So it's not like I said, I like that one. that one looks pretty good. Now it's completely random. So computer picked those out. Computer picked it all out, actually. I didn't do much. So this is the part that I did do, and this is always probably the most controversial part of any types of these modeling systems, is how you're going to weight the resistance layer, meaning like what's saying that this is optimal and not, and this is strongly avoided. So the way we did this, remember these are Fisher observations. So this is actually where the Fisher used and what was available to the Fisher. And the way to look at this here is down here are your headings to your columns. And if we look at just conifers and mixed forest, so they were used more than they were available, right, for Fisher at the roadside. They're above this kind of 50% line. So in the model, we scored those as 100%. So now this is kind of like not really, this is real information. The Fishers were using these two types of habitats at the roadside more than others. But for the model, 100% scoring basically means if that habitat's found on the map, that is completely permeable to the Fisher. It's not creating any obstacle to their movement. They can just zip right through that. Okay? This other one, this hay and pasture, was this much available and hardly used by Fisher. So they're strongly avoiding this habitat. They're not using it hardly at all. So we gave that a 1. So that type of habitat is very resistant to Fisher movement because they're just not using it. And then things that were kind of midline, like 50, we just scored as 50. Just, you know, a little bit of use, 50 right down the middle. Wetlands was used a little bit more. Forested wetlands, this is where we relied on the literature a little bit. Forested wetlands are pretty important for Fisher, so we scored them as 75. And this development and transportation, even though it was 50, we just said it was 1. It wasn't suitable habitat for Fishers because most of this, the road is always going to be in that circle regardless of whether the Fishers are selecting it or not. Okay, so that's how we weighted the whole system, and that's what's going to guide where the model's going to throw out that little red line on the map. Okay, everybody with me on that so far, kind of? Remember, that's all based on actual Fisher observations. That's how they're using the landscape. So this is the study area again, and here's the road going through the middle, 24 miles of it. So here's my blocks, block 1, block 2, block 3, and then all these light gray shapes in the middle. That's what the model gave us for the corridors. Okay, the black circles is those 250-meter circles for where I'm taking the mammal information out of them, for where the animals are crossing the road next to the corridor, and all the white ones are the random locations, right? So they're outside of those gray shapes. So there's 11 of each because we're going to test 11 versus 11 of random and corridor, and this is where the statistical methods come in. Basically, this first test is going to examine the number of species between those two, random in the corridor, between the random circle and actually where the corridor is. And the second one, the Fisher's exact test, that's going to compare, remember the species that are sensitive to fragmentation, black bear, bobcat, and Fisher. That's going to compare those species. Just a note, Fisher's exact test is not about the Fisher, it's actually the guy who made this test. Just happened to work out that way. So for the first test, number of species, okay? So here's the number of species. This is inside the corridor. So those are where the corridor was. This is outside. As an average, we had 7 species in there showing up. Outside the corridors, we had about 4 species showing up, okay? So in scientific language, that's a significant result, meaning there was a difference between those two, enough to call it significant, which means it supports the hypothesis that Fishers are more likely, well, no, that there are more species found in the corridors. So this high end of the bar, in some of the corridors, there was 11 species found, all the way down to some were not very good at all, 3. And for this one here, you had a high as up as 8, and then as low as 2, but the general average was higher on the corridors. Okay. This is the results for now fisher, bobcat, and black bear. And for both fisher and bobcat, they were both found in the corridors more. So they were present 8 times in the corridor. Outside, they were only present twice. And for bobcat, they were present 6 times in the corridor, and they were absent in all the outside corridor spots. So bobcat wasn't found outside of those corridors at all. And then bear didn't show anything. They were found just the same in both. So it wasn't a significant result.
Would they be hibernating in the winter? Is that the word you did the study?
Right, but we did get a little bit of observations. We got about 50 bear crossings from April into May. And that was the only way we sampled them. So it's tough to know if they're going to use those corridors other times of the year, because they really change a lot of their movements throughout the year based on what food sources are available. But I'll bring that up in a little bit more in the discussion.
Yeah, maybe bears aren't averse to open pasture the way fish are got.
Yeah, you're all right ahead of me. Yeah. So that's exactly what this data will show you in a second. Yeah. Okay, this is just a big list of all the animals that were found throughout the study in scientific name, Latin name, and then so a lot of red fox. We had moose, and these are the ones that the corridor intercepted. Yeah, we had one lynx. You might have read about that one up there. It drew all sorts of press up there when we found the lynx up there.
You saw it?
I wasn't on that day, but my co-worker, he found it. Yeah, it was a pretty cool story. So we've one lynx. There's a lot more sightings of lynx tracks up there this past winter around that area, northern New Hampshire. I know of at least 4, and I was on one of them that I saw. Okay, so just a couple more things here. The model, this is talking about the corridors, it only picked up 35 of 117 fisher crossings along that whole length of road, only 30% of them. So it's not getting all of them. Got a fair amount of bobcat. Bear didn't get many. So this total over here is how many black bears were documented in the whole study, how many bobcats, fishers. This is how many of the corridors got. And then 19% of all the crossings were intercepted by the corridors. But these corridors are pretty small. Generally, the size corridors we're testing here are much smaller than you'd actually want to think about conserving. Corridors should be much wider than what we're using here for these testing purposes. So a lot of animals up there to document. Am I going the wrong way here? Oh, okay. Well, geez, how much time do we have? Because this is...
It's 8 now.
Oh, okay. So, geez, I went on much longer than I did in my trial run. Okay, this is just going to breeze through these real quick because you're not familiar with the study area, but these were the zones that were best in the study. Just a quick thing. So this is just going to give you a perspective of what these things look like from above. And these are some numbers. So this is a number of species. This is a good corridor, a really good one that had about 11 species documented: fisher, bobcat, bear. And this is what it looks like. So this little white line here is the outer edges of the corridor, and this is the habitat in the middle. So you can see what the habitat looks like on the outside edges. And then this darker green in the middle, that's coniferous habitat. That's that power line. There's the road. So you're getting a sense of what these look like from above, what the model's looking at. Same thing here. Right. This one had 11. This one here had 10. So you see the model's doing a pretty good job of avoiding these areas. It's supposed to. Same thing. I just want to get to this one here. So this one's interesting. So this is one that the model predicted. Had no fisher, no bobcat, no black bear. Very little moose, very little red fox, although the model thought it would be a good one. So remember, this is the outer edge. But on a real micro scale here, you see this field that comes all the way along here. You got this house here, you got this house here, you got this development house here. And so really this area is really just this little connector right here. So it's just interesting to think of just how just a little bit of development along the edge of a road can really change how animals are going to move there.
Can you say, by looking at that, like, what is the space between that, 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30 feet? What is the space between that? 10 feet, 20 feet, 30
How wide is that? That's 200 feet. So we're roughly looking at about 200 feet, maybe a little more than 200 feet.
Okay.
Yeah. So really not much. The width of the whole thing is about 200 meters across the whole way. Discussion, conclusion. Okay, so yes, the corridors that we did, there was more species showed up there. Fisher and bobcat were detected more frequently there, but not the black bear. Why? And like people were alluding to already, hay and pasture and hardwoods, this is basically a way to look at land cover use. Bobcats and fishers didn't really use these types of habitats at all, whereas for the bear, they use that habitat quite a bit, hay and pasture, and the hardwoods much more than either of these two. Whereas the bobcat and fisher, you can see they really use the conifers, where bear not so much. So it excluded bear from being in some of those spots. Okay, does that kind of follow up on what we were pointing out there? Yeah. So it doesn't it makes complete sense. I mean, the model was built around conifers and mixed forests being really strong, hay and pasture excluded. So, so here's just some more follow-up. Yeah, we'd like to test this model out somewhere else. There's a lot of models like this going around all over the states of New Hampshire and Vermont, and it doesn't have to be our model, but just any model like this should be validated in the field. Like something like we did, or to the best of the ability of the study. So this was interesting, is that the fishers were documented at the roadside crossings. The habitat was similar to these other studies, like these people, where they did these studies way away from the road. The habitat was still similar, what we found at the roadside, than to what they found further in the forest. So the animal's moving across the landscape and really staying in its preferred type of habitat to get from point A to point B. And I just said that. Okay, yeah, we'd like to test. I already said that. Here's a big one. So the whole model's built on this one factor of land cover. We didn't include topography and all these other features which may be important. Those should be included in future models because they're going to stick around a lot longer, topography, rather than land cover. A new development, a new house can go in there, and if we're basing all our information for selecting a corridor for protection or whatnot, or conservation, if the model's from 2005, it's out of date. There could have been a lot that's happened in there. We don't know anything about other critters other than mammals, and we only know about them for a short section of season too, almost half a year. Whether frogs and turtles or birds, whether they're using these spots as well, we're not sure. So other studies should look at how to factor in those critters and how to survey for them. There's a lot of models now coming out that are incorporating like a few different species into kind of like a mega model. They take fisher, bobcat, wood turtle, etc., and then they use that as the guiding principle. I don't know if it's just going to muddy it a little bit more. I'm not sure. So thanks to these people, and questions and comments. And just one little thing here. This, if you ever get a chance to see following a fisher, this is the fisher has jumped out of the tree and left a little snow print in the ground, the full body length there. So that's the tail. There's the body. There's the head coming down. This is where it gets up and walks out.
Are they jumping on prey?
No, that is just because like they climb trees, they'll start coming down head first, and then that last 3 or 4 feet, they'll just dive out and boom, right into the snow. And if you measure that, I don't remember measuring it that day, if it's over something 30-something inches, 35, 37, up to 48, it's probably a male. You could probably determine that by the estimates I gave you earlier. All right, thanks. Yeah.
What is the interaction of this mammal with people, with their pets, like dogs, cats?
Mhm.
Do you have any feel about that kind of thing? Do they
Yeah.
avoid them, or?
Well, there'll probably be some avoidance of dogs. Cats and other critters, fisher gets a bad rap, which probably many of you know, of being a real preying upon cats. And I want to make sure that I could address that tonight, and I found a study from Massachusetts which looked at fisher scats, 100 and something fisher scats and 50 intestinal tracts of fishers during the trapping season. And domestic cat was only found in less than 2% of all those scats, and this is around the developed area. So it's really not as much as people probably think that they're preying. I mean, the cat is just as likely to get eaten by a bobcat or a coyote or something else. So yeah, there's definitely some interaction. Like I said, they might not be as sensitive. People are starting to find them in suburban type of fragmented zones pretty commonly. But as for suitable habitat, they're really not spending a lot of time there.
Going off of that, what do you think about, I don't know if you've heard of the study they're doing in Albany, looking at personality of fishers, and they were putting out like flamingos, plastic flamingos in the
Oh,
woods,
really? I didn't hear
and,
anything.
Yeah, filming reactions
Really?
to see how they would react to coming across things in developments and stuff like that. That they're hypothesizing that the more braver fishers would settle closer to humans. Vice versa.
That's probably the juveniles. You know, they're out there looking for new habitat, and the adults who are kind of maintaining these source populations are really the ones that are important. Because if that habitat gets altered much, then it's going to really change the social dynamic of the whole system. But they're not as sensitive as people's thought. I'll have to find that study.
How territorial are they in terms of, you say they have such a range, do they really aggressively defend that against others, or are they just kind of mixed?
Yep, that's a defended territory amongst their own.
For the males?
For the males, remember the female ranges will overlap the males, but the females will defend their territories and the males will defend theirs, except during the breeding season. For the males, they're going to start to spread out and they'll have interactions around certain females that are ready to breed. So they do have like a rut, you know, where they're going to go at it. There'll be some serious fights going on.
And how quickly do they breed after that birthing in March? When do they become breeding adults?
Oh, okay. The females in their first year. So once they're born, they go around. The first year they'll breed. Males can breed, but they are not able. The penis baculum isn't strong enough to be able to inseminate the female, the technical terms. So they've got to wait all the way to the next year. The baculum is the penis bone for the fisher.
Do they have any sound patterns? Do they make noises?
They do have some vocalizations, but it's not like something you probably hear out your back door all the time.
We didn't hear a fish attack.
It could have been a barred owl. Barred owls often make this screech.
Stress was grunting, it was
Yeah.
horrible. I don't know. It was like you were
Raccoons, they really go off too. Yeah, that's a good one. Porcupines too.
What are the predators of fisher cat?
Not a whole lot. Great horned owl is really one of the biggest.
Maybe that's why they don't want to be under the trees too.
Yeah, so they're not out in the open. That's a good possibility. Other predators, vehicles, they're pretty tough. I mean, there are not a lot of things around here. Out west, maybe cougars or something like that, but not a lot.
Bobcats aren't after?
No. In fact, they can actually prey on bobcats sometimes. Yeah. And fawns. They'll take a lot of fawns. I forgot to mention that in the diet. Fishers will take fawns.
Do you have any data on activity during certain times of the day?
Not mine specifically, but from what other researchers say, most active early morning into late, crepuscular times, into the evening, most active. Yeah.
Have there been any remote camera setups that correlate with kind of the data you've been using with these zones?
Setting up a camera at a crossing zone, let's say, to see if they cross. Cameras are a bit tricky. They're better for culverts and tunnels because they're really funneling the animal in a specific spot. It's tough to set up a camera on a 200, 300 meter wide thing to know if the animal's going to cross exactly within the range of the camera. So they're a bit limited in this type of study. The snow tracking survey is the best way to give you the most information on the mammals, unless you've got a bridge or a culvert that you can set it up in. Which they will use culverts a little bit, but they didn't really use them a whole lot in the study. Yeah.
Do coyotes and bobcats affect how the fishers use ranges?
Geez, I know I've read a few things about that. they're all intermingling out there. Some of those predators are a little bit more specialized, where the fisher is a little bit more generalized in its food. So they're all competing for resources out there. So the fisher is actually having a little bit more of an impact on those types of populations, because they could take a little bit from this type of resource, from let's say what the bobcats are selecting compared to what coyotes are selecting, and kind of just put a little bit more strain on other species, just because they are so generalized in what they can do.
Coyotes prey on fishers at all?
I haven't come across anything on that. No. I don't think so, but I have not seen anything about it.
Have you photographed any fishers yourself?
Not in the wild, like out there on a trail. Thanks for coming.
So I had the opportunity to photograph one a couple of years ago. I live near the Wilder Dam, and it was in the open area,
Yep.
and I probably watched it for almost 10 minutes. And like you said, it was in an open area, but it followed fence lines and stuff. And you know, I got several good photos of it. And then it crossed. It was in March. There was ice on the Connecticut River, and it crossed the river into New Hampshire.
Oh, neat.
So it was.
That's really neat to see. Yeah.
Pretty interesting.
Yeah. I've seen fishers. You know, they've come up to the house. They've tried to. Well, we saw one try to take one of our chickens this past summer. So we didn't get a photo of it. They're a pretty easy animal for trappers. People who do trapping, they're an easy animal to trap. And if you're good at doing photo cameras, you can hang sardines or some sort of something that really attracts them on the edge of a tree, and they'll come up and you'll get a lot of photos, and have a few photos like that, but not really great quality ones.
But when I observed, the closest photo I got was a little bit closer than from me to you, and it was actually, it made me a little bit nervous because it had no fear of me whatsoever. You know, it was just looking right at me, you know, and I took a couple nice photos of it, and then it just kind of trotted across the river.
Yeah. I've been in the forest just trailing along or looking at something and just see them kind of go by. They don't really seem to pay much attention, which makes me feel they're not really too worried about,
Right.
about us. Yeah. Yes.
If you were to look at your data differently, from what I understand, you had the zones that you predicted
Mm-hmm.
animals would cross, and then compared with random zones. But if you just took all your data and just looked at where fishers crossed, irrespective of anything else,
Yeah.
would it come up with the same result?
Yeah, I did that too. Kind of like my first trial run, I just said, let's just look at where fishers are crossing, let's do the same thing, random locations, all that. And it still did show up this significant result. The only thing with that is I wanted to test this modeling process because it provides a little bit more for people to work with in the conservation field, because a lot of people don't have that type of data that we were working with.
Not anyone can take 7,000 observations.
Right, right. So if we could use the data and then say, well, with this modeling, we can then find locations, then we can start at that process and just go out and test them. So I thought that question provided a little more, but it did do what you're saying.
Yeah, so it actually backs it up.
Yep. Yeah, yeah.
What type of area, or do you know, what type of area does the female give birth in?
Mm-hmm.
The natal
Yep.
territory, what might that be?
Yep. Yeah, I forgot to mention about the denning and the resting sites. So the natal denning spot and the resting spots will be in lowland coniferous forest areas. So the coniferous forest is extremely important for the resting and denning spots, all times a year.
Do they burrow at all?
Yeah, well, just like maybe a denning spot sometime. Okay, so where they'll be will be in the natal den will usually be up in a tree cavity. It could be 20, 30 meters, pretty high up into a little cavity. And the resting spots, just general resting spots, could be up in a tree, or just under a brush pile or under a rock jumble or something like that. Yeah. And if you're following a fisher in the winter and it does go up a tree, don't think it's just denned up there. Really search around all the trees around you, because it could easily just jump from tree to tree for a little bit, moving through, and then just come down this other tree and keep going. And then maybe you'll find that at the end of it. So look around for that if you see them go to the tree. Yeah.
When you set up your blocks 1, 2, and 3, was there some differential resource in those such that you predict
that they would bother to cross at all? Like, I don't know why, if they're barrier sensitive
Yeah.
and you had a nice coniferous area, why they wouldn't just
Mm.
avoid the road unless you're picking up some of the more
Mhm.
sort of brave individuals or the ones who are getting pushed out of the territory. or-
Okay. Let me think about that. So the blocks, so that's White Mountain National Forest, pretty much all around that. So most of the development is pretty much along the roads there.
So it wasn't like there was a special body of water or a special type of tree or a special something that would have made them, I wanted to get across the road to get to.
Not just big,
some of
big,
the
big.
resources.
I mean, there's big habitat. I mean, big country out there. Not a lot of development at all. So they just want to get there because if it's during the breeding, they just want to go. The male will explore those areas looking for more females that have territories set up in those zones. Or you might have a home range that's just right based on the road that is actually split by the road that it's actually going back and forth. It's hard for me to say because we didn't have the animals collared, we didn't have individuals to see how they're actually using the zone, but the habitat all around it, like why does the fish are going to cross the road if it's such great habitat? You know,
They're major predator cars, you'd think they'd have some
Yeah.
diversion.
it's hard to say. You know, they're going to go out and do what they want. They're going to look for more food. They're going to look for resources. And during the breeding season, the males are just not going to worry about roads. They want to find as many females as possible. So, okay, I got you already. How about I got you already? Have someone who hasn't
Yeah.
had one. Okay, last two then.
Will they follow a hunting route repeatedly?
I doubt it's probably the same route. I think maybe some of where these road crossings are going to be the pinch points that they will follow, but they probably funnel out. But there are probably certain places that they'll go to frequently, whether that's a good place to hunt hares or that's a good place to hunt porcupines, and they'll go to those spots regularly. But I don't think it would probably be the same route all the time. They'll probably zigzag all over the place like that. Yeah. Okay.
Any estimates on population now, and how has it changed since the introduction from Maine?
In Vermont,
Uh,
the study
the
on
introduction, you said they came from Maine, you introduced them to, or returned them, put some new ones in
yeah,
Vermont.
in 1960. Yep.
So how's the population grown and what is it now?
Oh, right now it's pretty much stable. There is a trapping season in Vermont that's monitored pretty closely. I wouldn't say it's high or low. It just seemed to be a successful reintroduction. Yeah. Yeah.
Well,
Okay. Yep. Thank you.
I'm sure that maybe, I don't know if you want to stay for a few.
Sure, I'll stick around for a few minutes after.
I think that probably we should let people stand up.
Yeah.
But thank you very much.
Yep.
And, you know, it's great.
Okay. Thank you.